Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next big offer. Today, we're going to talk about an easy problem, kind of slack. So the problem is shortest word distance. So essentially, giving you an array of lists. They want you to find the shortest distance between these two words in the list. At first, I got a little bit confused because I was like a coding and a practice, why it's 3, the shortest distance, because practice index is 0 and coding index is 3, so it's 3 minus 3, so I guess that means it's distance 3. But then what's the point of doing this? Oh, and then if you check, there's actually there could be duplicate word, right? So there could be makes and makes. So if you're asking like makes and coding, so then it should be 1, because these two will be it instead of this makes and coding. So it is not the added distance problem, which I'll cover it later, which is harder than this one. But this one, given that said, so there's 2 ways, right? One way you can brute force it. So for each of the word, you find the closest distance with the other word. And another smarter way is basically ON solution by having 2 indices counting each word. The reason we can do this ON is so this is a quick thing, right? So assuming this is the array and then word 1, word 2, word 2, word 1. So you have 2 pointers, right? First you calculated I1 and I2, so now you have a minimal distance. You find another I2, you calculate minimal distance, but it's actually larger. So you still keep the original minimal. And now you see another word 1. So the greedy part is more like, so you can simply just calculate this distance instead of this again, because by nature, as long as they're closer, they should have a smaller distance, so that you don't need to do this brute force. For I1, you have to calculate back this I2 because these two will just be closer. You calculate this 2 and then you compare with the existing minimal. Regarding implementation, some of the so essentially looks like this. You do some sanity check, different word index, starting from -1, the initial value. Given a larger value, you can also use integer.max. So the way I like to implement it is, as long as you find a word equals to either word 1 or word 2, right? You record the index. You will only compare if the other part is not -1, which means you find both part. And then you have the minimal distance, right? So calculation. Another implementation people sometimes do, they put the minimal distance, this update to every single index update, which is totally fine. It doesn't really impact the time complexity. It might be easier to read, but just wasting kind of CPU cycles if they only have 2 words and the array is super long. So you don't need to kind of not 2 words. Let's say if the array has only like 3 words appearances, but this array is like super long, then you just keep updating this, just doing nothing. So I just keep it this way. Time complexity ON, this is the array size, and we don't need any extra space, so it's constant space. Relatively straightforward problem. Yeah, that's it. If you have any questions, feel free to leave any comments. If you like the video, hit the like button and subscribe to my channel. Thank you very much. And also check out baozitraining.org for mock interviews. All right, thanks guys. Bye.